Hey everybody, in this example we are going to determine the values of missing constants a and b such that the function, this piecewise function, will be continuous on its entire domain. We're going to solve algebraically and then graphically. Okay, this problem is unique in a couple of ways. For one thing, we're finding out how to make it continuous, and the other thing is my domains are written as inequalities. The inequality x minus 3, absolute value of x minus 3 is greater than 5, is basically saying the distance between x and 3 is greater than 5, so some value in 3. So what x's would satisfy that? It's going to be an outwardly interval, like negative infinity until this, and then this number to infinity, and vice versa in a way. The distance between x and 3 is less than or equal to 5. Well, that's going to be, a closed-in interval in between two places. So we're going to solve our domains more thoroughly. And then we will figure out where the graph, that we have ends and begins. And then we'll write the linear equation, ax plus b, that will fill it in and finish it and make it continuous. So let's go. All right. So the first thing, I'm just trying to get my bearings where I am. Okay, there I am. Just want to make sure, am I on the screen? Oh, I see. Okay. So I'm there. Okay. Sorry, I'm disoriented. So I'm going to deal with that guy in pink over here. So what do I have? I have absolute value of x minus 3 is greater than 5. Now, if you're in pre-calc, it's probably been a minute since you've had to solve something like this. When you have an absolute value inequality, the way you solve it, think two lines. I'm going to do two different inequalities. So the first inequality will be same. So what does that mean? You take the inside, x minus 3 greater than 5. Same sign, same number. Then we're going to also do x minus 3 is less than negative 5. Okay? So that's your change. Now, if you think about it, like what kind of a number can go in here overall? I mean, we could get something like the number 6, but we could also get something like the number negative 6. So that's why these two statements here cover that. I'm going to add 3 to the other side, right? So that's going to get me that x is greater than 8. And I'm going to add 3 to the other side over here, and that's going to get me x is less than, if I add 3, negative 2. Now, what does that look like? I'm going to erase this work in a moment, but that little number line, if I kind of plot everything, negative 2, 8, they're both open circles. So I want greater than 8, or I want less than negative 2. So what is the domain for that? What is the, I didn't mean to erase the little star because then I'm going to lose my place. What is the domain then? It's going to be from negative infinity, right? So negative infinity until negative 2 union 8 until infinity. Okay, that is the domain for the first part. I think it's a little bit maybe self-explanatory in a way that the domain for the part below it is going to be between negative 2 and 8 with brackets instead of parentheses, but we could still work it all the way out, right? Let's even move like that. Okay, so now this guy in blue, right? So the same idea, absolute value x minus 3 is less than or equal to 5. So again, you're going to do same, change. Two lines help you to remember two equations. Keep everything inside the same, x minus 3 less than or equal to 5, and x minus 3 is greater than or equal to negative 5. Add 3 to the other side, x is less than or equal to 8. Add 3 to the other side, x is greater than or equal to negative 2. What does that look like on a number line for a visual? So it could be equal and greater than or equal to negative 2, yet less than or equal to 8. So there's your little region right there. So what is the domain of the blue, the one designated as blue? So that's going to be bracket negative 2 until 8. Okay, so now if you ever see a domain written in that way, just know that that is how you would solve it. Now, how do I write the linear equation ax plus b to make sure that this is continuous? So I'm going to do it algebraically first. So I want to know basically when this first graph, okay, this guy, okay, this guy, when that first graph ends going from left to right at -2, even though it's an open circle, what's the y value? -2 is the x value. So f of x means, where is f of x? F of x, that means y. Y is -half absolute value, x minus 4, yada yada. So all you have to do is find the f of -2 in a way. It's not true because like we're plugging it into the top equation. For the top equation, I'm putting little quotes around it because really if I were doing f of -2, I would really fill it into the bottom of the equation, which I'm trying to solve for. Hopefully that makes sense. -1/2 absolute value, -2 minus 4 absolute value ends, plus 2. So that's -1/2 absolute value of -6 plus 2. -6, if I take the absolute value, I get 6. -1/2 times 6 plus 2. That's -3 plus 2, and that is -1. So what does that mean? That means that the ordered pair would be -2 for x, comma, -1 for y. So that's where the one graph ends. So I'm going to erase the work that goes with that now. So if you need to watch it again, go back and watch it again. So that -2, that's telling me where the defined graph that is going from -infinity till -2, where that open circle gets drawn. Now on the other side, I'm going to find the, in a sense, right, the f of 8, again, little quoties. So I have -1/2 absolute value of, well, not x, I'm going to fill it in now, 8 minus 4 plus 2. 8 minus 4 is 4, absolute value of 4 is 4, -1/2 of 4 is -2, and -2 plus 2 is 0. So what does that mean about the point? The point is 8, comma, 0, where the second portion, 8, comma, 0, where that second portion of the graph is going to carry on from, right? So those are the 2 points. So the one point is over here, -2, comma, -1. The other one is over here. Now, if I want to make this continuous, okay, with a linear equation, right, ax plus b represents mx plus b, y equals. So what can I do to figure this out? I mean, there's a few ways we can do it. You could start over here with that form of the line, yada, yada. I'm going to start off by finding the slope. M, or A, is the slope, change in y over change in x. So I could say 0 minus -1 over 8 minus -2. That becomes 0 plus 1, which is 1. 8 plus 2, which is 10. So the slope is 1 over 10, or A is 1 over 10. Again, I'm going to erase, so if you need to look at it again, what I did, you can rewind, but I'm going to show it graphically. I think it'll make more sense when you see the graphical interpretation of it. So that is -1 over 10, okay? Now, to get the b value, you could pick either ordered pair. Neither of them is the y-intercept. So I can pick either 8, 0, which has a 0 in it, or I pick -2, -1. So if I fill in -1/10 for A, if I fill in, say, 8 for the x, right? And make sure I'm filling it right. Then plus b is what I'm going to be solving for. And y is 0. Well, then I get 0 equals -1/10 times 8 is -8 over 10, or -4/5 plus b. So what does b equal? Well, add that over to the other side, and b is 4/5. So I'm going to erase again, saving the space. Too bad I don't remember -1/10 and 4/5. So what is the equation? Y equals -1/10 x plus 4/5. So A is -1/10 and B is 4/5. So that was done algebraically. So I'm going to take that and kind of write it down on the side, and then I'm going to pull up a graph. So I'll write down what the answer I got was. -1 over 10 x plus 4 over 5. And then in the pink, the other ordered pair we got was negative 2, negative 1. And let's erase all of our work. Okay, so that's the info we had gotten. Now, I'm going to pull over a graph. Well, so much for that because I'm about to take over the screen with this. Let's see what I could do. Okay. And let's move. I'm going to move the little equation down here. Okay, so I'm going to take the same equations over here, right? And let's graph them. So in pink, I'm going to go to the right 4. 1, 2, 3, 4. I'm going to go up 2. There's the vertex. Now I'm going to erase part of this graph in a little bit. And I have this piece of graph and it's down 1, out 2. So it's like this, down 1, out 2, down 1, out 2, down 1, out 2, and I'll just do a few more. So that's part of it. Okay. Now we did that domain on the side, and what did we say about that domain? We said negative 2 to 8, right? Okay. So that means negative 2 to 8. So I'm going to take the eraser. Negative 2, I'm going to make an open circle there. And then it's going to start up again at 8. So what is this? 1, 2, 3, 4, 5, 6, 7, 8 is right there. Okay, make that an open circle as well. So that means that's an open circle and there's an open circle. Now, what are these ordered pairs? Okay, this ordered pair is negative 2, comma, negative 1. And that's exactly the point we just found algebraically. And then that point, well, that's 8, 0. That's the same point we found algebraically, right? So now what I want to figure out is I want to get the ax plus b, so that linear equation, right? I want to get that equation that makes it continuous. So it's going to fill in this hole, and connect the dots like that. Okay, can I figure out the slope all by myself like a responsible young student? Sure. So I'm going to go count it up. Up 1 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the slope is 1/10. Did I write negative 1/10? How did I do that? 0 minus negative 1 was 1. I think I just like miscopied somewhere, right? You guys will have to tell me. Yeah, because that would have been positive. Oh, I think like, yeah, maybe I plugged it in wrong. Because that should be positive 1/10 if I did change in y over change in x. That's so weird, right? Negative 1, that's a y, minus 0. Well, either way, I did it the other way, right? I had done 0 minus negative 1. What am I doing, huh? Over 8 minus negative 2. So that became 1 over 10. So if I fill in 1/10 and solve, I'll get negative 4/5, okay? So, error on my part. Guess what? Not re-recording. Go back, find my mistake, see what I did wrong, fix it in your notes, okay? You're smart. You'll figure it out. I believe in you, okay? You should believe in you too. Okay, so I want to connect those dots. We said that the slope of that line, or M or A, whatever you want to call it, M, which is A, is 1 over 10. Okay, and from there, my y-intercept. So again, it's up to you which way you want to do it. We could just do like we said, y equals mx plus b, and go from there. So y equals mx plus b. Let's plug in. The y value was 0 equals m 1/10 x, which is 8, plus b, and this negative 1/10 times 8, that's 8/10 or 4/5. And then bring it over and you get negative 4/5. So the final equation for our answer ends up being, where can I write it on here? Is ax, oh Jesus, plus b equals 1 over 10x minus 4 over 5. Sorry, this was a bit of a mess. I didn't really leave enough spacing for it, and it was awkward to show. Hopefully that made sense. I know it got a little long. Ugh, 15 minutes, gross. I'm so sorry, guys. But hopefully it made sense to you in one capacity or another. So fingers are crossed for that. If you're happy, you know it, thumbs it up. If not, thumbs down. I'm going to a couple more piecewise functions I have to record, and then I'm going to go into the rational functions and record a whole bunch of those. Questions, comments, concerns, links, requests, go in the comment section. Adios.